Dear students, in this short video, we will see one concept on recursion, that is toes of Hanoi. You will be given three poles A, B, C. A can be treated as source pole, B like intermediate, C the destination. In this disk, in this no, the plates are arranged in the order of their size. The higher size at the bottom and the lower size on the top. For any moment, the lower sized plate cannot be on top of higher. That is the thing. You are asked to move all the plate in the same order from source to the destination. You will be moving all these plates from A to C. You can take B as a temporary. Okay, so you'll be given this kind of situation. Initially, all these plates are arranged in the order of their size in that pole A source, and you'll be moving that to C. After moving, this is the arrangement. This is the thing required. So we'll be bringing that recursion concept here. How we can make use of recursive function to move all the disk. Some conditions. At any time you can move. You can move only one disk at a time. Larger disk cannot be placed on smaller disk. Smaller can be placed on top. Suppose this is the indicates if this kind of thing is given, this program A is moved to B. That is the meaning. The smallest program will be given n number of disks. Will be moving from source to the destination, keeping temporary TMPS the intermediate pole. Source to destination. This is a temporary. You are moving n. Suppose no disk is given, stop. So you will be nearing to the answer. Otherwise, call this recursive function again. Each time will be near to the answer. N will be decreased by 1, n minus 1. Here, move all n minus 1. There are n number of disks. Okay, keep that the higher sized disk there only, and move all other disks. Like you'll be dividing whole set of disk into two parts, 1 and n minus 1. One disk you keep and remove remaining n minus 1 disk you have to move to the temporary. Okay, so this is the way. Move, you call tower of Hanoi, n minus 1, source, destination temp. Now destination act as a temporary. Okay, so how to remember this? You keep that source as it is, you have to interchange. This last destination now becomes temporary, the temporary now becomes destination, intermediate only. Okay, once you do like this, and you see that value reach to then you print, you actually moving from source to destination. As in the previous step, we kept all the things on the temporary. You have to move from temporary to the destination. Now it is reverse. Now, temporary you bring it to the first place. Temporary bring it to the first place. Then earlier source like act as a destination. The temporary, the earlier destination now act as the destination only. Okay, how to remember? Temp in the first place, source and destination. Write it. This is a C program. If n equal to 0, call terraform y n minus 1 source destination temp. Okay, you print from where you took source to where you moved destination, the pole number. Then that n minus 1, you have to move from temporary to destination, taking source as a temporary node. We'll see how this is done in the simulation form. You will be given three disk, three poles A, B, C, three disk, three poles. Is n is 0? N is this one. Is n is 0? No. Then in the next step, n minus 1, 3 minus 1 is 2. Source as it is, you interchange these two. C, comma B. Is n is 0? No. Again, n minus 1. For the next step, no, this becomes n. N value now 2 minus 1, 1. Keep A as it is. You interchange these two. B, comma C. Is n is 0? No. Again, you proceed. 0. Source as it is, you interchange C comma B. Is n is 0? Yes, n value is 0. Then In the what is the value of n in the previous step? That you have to print 1 AC. That means disk number 1, the top, the smallest one, moved from A to C. So it is taken from here, kept over here. So one disk is moved. Still, you can see these are in the proper order and this is moved. Now we have reached half part of that, remaining half part, n minus 1. For the next step now, this is the n value, n minus 1, 0. Temporary now becomes the source. Temporary in the previous stage now becomes source. Then earlier the source now becomes temporary, earlier destination only. BAC. Is any 0? Yes. So in this step, from where it was called? From here. So you have to move disk 2 from A to B. That's the meaning. You have to move disk 2. 1, 2, 3. 2 is the next one. You have to move from A to B. Now, below part. 2 minus 1, 1. Temporary. C, A, comma B. Is any 0? No. Break again. Next step. 0. Source. Same. Interchange b comma a. Is n 0? Yes. For this step, what was the n value? N value was 1. So earlier it was here, you have to bring it here. See, in this step also it is properly arranged. The smaller disk on top of bigger one, this is untouched, this is emptied. Disk number 1 was in C. Now we have to bring it to B. Okay. Next, down path. N minus 1, 0, A, B. Is n 0? Yes. Previous step, from where it was called, from here. Move disk number 3 from here, plate number 3 from here A to C. You keep it on C, in the pole C. In this case also, all these are not violating or proper in proper order. Down path. 3 minus 1, 2. B, A comma C. Is any 0? No. Next step. N minus 1, 1. B as it is. Interchange these two. C comma A. Is any 0? No. Now, n minus 1, 0. B, A comma C. Is any 0? Yes. So this is called in this step. Now, move disk number 1 from B to A. Move disk number 1 from B to A. So you are bringing this to here. In this state also, all are in the proper order. Down, n minus 1, 0. Temporary now becomes source. B, comma A. Is any 0? Yes. So how it was called? Called from here. Move disk number 2 from B to C. You keep it over this disk. Again, this is in the proper order. Now, downside of this one. 2 minus 1, 1. Temporary now A, B, comma C. Is any 0? No. Split again. Yeah. 1 minus 1, 0. Source A, interchange C, comma B. Is any 0? Yes. Move disk number 1 from A to C. It was here, you bring it to C. You keep it on C. Already it over there. So you keep this one over here. Almost all the disks are over, but we'll see that in the algorithm part. Tower 0, B, A, comma C. So all the disks are moved successfully from pole A to C. At any step, you have to keep this in mind. Smaller disk can be placed over bigger one, but vice versa cannot. After the completion, you have to make sure that all the disks are placed from source in the destination disk. So source was A, destination is now C. All the disks are properly arranged. This is how the plates are moved from one pole to other with the help of recursive. The same operation is repeated again and again. The function is calling itself again and again. Each time it is calling, it is near to the answer. When it reaches the answer, the program stops. Thank you.